Okay, hello, welcome back to the channel, everybody, and welcome back to Let's Make Snake. So, I lost footage again. The game, when you see it last, had Snake moving around the screen with no turning of the tiles, no rotations of the tiles, anything like that. It was literally just a Snake moving around the screen with all the tiles pointing upwards. And then done another 1 hour of recording, 1 hour of recording, and ended up with this. So here we have a Snake who is going along in the right direction, and when we press WAS or D, he can turn corners, and he turns corners correctly with the corner matching up and everything. So, how do we do this? Fucking ignore that. What we done is we started by doing this bit, which is basically setting the new position of the head, the Snake's head, and also the direction. So we made a new struct called level info, sprite, direction, and draw direction, and that's what's passed in the grid. I can't remember if I did that in the one before or not, but I think I did. But it's got the sprite and the direction. I don't remember if I did or not. Anyway, yeah, I must have done, because that's how I stored the sprite. And yeah, I think I did all this as well. So all this is obviously what we've done in the last one. What we did do is we switch the in here we had a direction. The reason we had direction is so that we know which way to draw them. As I said in the last one about the direction that you're moving in is stored the direction that it come in at rather than the direction it's going. We did make a looping bit, which is this here, which just adds level X and then uses modulus level X, so it just leaves us with the remainder. And we added draw direction as well, which for every head position will always be the direction it's moving in, which is easy. And so we then had this to deal with. The Snake's tail's draw direction is just drawn at the last direction, which is the direction of the tile before, basically. This just makes sure it patches on to the end of the Snake. And then we made a new function called get corner direction. Now get corner direction takes last direction, the current direction as well. That's this function here, and basically all this does is uses the last direction and the current direction and works out how we should be drawing and how we should be rotating, how we should be rotating the corner piece in order to connect the corners up correctly. And all we done is down here we had, where are we? Here in our draw function. We literally just rotate them before we draw them, and we just rotate them by draw direction, and draw direction is set as the direction at first unless it's a corner position, in which case we set it manually, and it calls rotate and then it calls get rotation from this, and all this does is just takes a direction in and rotates accordingly. Now this works with the body, this works with the head, this works with the tail, and more importantly, thanks to the other function we done, it works on the corner pieces as well. It took me so long to work out how to work out the corner pieces, like there was so many iterations of doing that, and yeah, eventually it worked. It was very confusing to remember it's like the direction it comes in at and stuff like that. Let's just move that off your screen so you can see this a little easier. And yeah, look, now so when we go off the screen and come round, we stop drawing up there and we draw our new one instead. So yeah, that's pretty much what we done, was we made that so that it does that, so that it can actually looks like a proper snake. So what we're going to do in this is we're going to tidy up a little bit, and the way we're going to do that in sprite.cpp over here, remember we worked this out, the SW and SH, we need to add on, we're going to we'll do them at the end, we're going to make a new int called screen W and then a new int called screen H. So the reason we're going to add these on, if we just do it like that, is in here we need to make this so that it works with any size screen and not just a 1280 by 721. So we do that like this, and then the 16 by 9 that we get, we actually have to use a an aspect ratio. So if you look in here, we set the values here, didn't we? We could put all of that. We could probably move all the camera and that over, which we might do in a minute, because I might move all of this over actually into the engine in a bit, but we'll do this in a second. What we're going to do first is just make a float and call it aspect. There we go. And that equals the float version of screen width, and we divide that by the float version, definitely said float, of screen height. That gives us aspect. And here what we do is we need to then make it a whole number, don't we? So how do we then make it a whole number? Because obviously it could be a 4x3 screen, it could be a 1x1 screen, it could be anything. So we could just do this as aspect and do this as 1.0f, and then in here if we just copy the bit of code to get aspect. This is just to make sure it works. It should work. There should be no reason it shouldn't work, but and we'll make 2 new ints here and call it that definitely had we'll call it screen W and make that equal 1280, and make a new int, call it screen H and make that equal 720, and then we just sub that in for there and sub that in for there, and then aspect can go there and that can be 1.0f, and now it should look identical. It shouldn't look like we've done anything if I've done it right. Nope, there was build errors. Of course there was build errors. There is always build errors. From initializer list to sprite, and because we didn't include the screen width and screen height. Now they can just be brought over, I guess, because, you know, we're good at coding. Oh, let's undo that, delete the int, and delete int, and just copy that, paste it, and paste it, and snake H, paste it in there as well. We need to add the ints back in, and then in main.cpp where we make snake, which is there, we'll just include them as well. Now try and run it, and hopefully it works. No, of course it doesn't work. What do you take me for? Sprite now overloaded takes 8 functions. Sprite for level. We need to pass this the screen width and the screen height as well. Okay. We're just gonna have to do this, won't we? This is gonna suck, because we have to do this and do this. Head over into here. Send level these as well, and also in level.h we're going to have to include screen width and screen height. Should really find a way to just make that retrievable from anywhere, really, but that's optimization. As I keep saying, optimization comes later. But yes, as you can see, the screen draw is exactly the same, no different, which is just what we needed, which is good. Next, we are going to look into making this. So at the minute, all we do is do time plus one, time plus plus, and then we call the functions below it. We're going to look into making this actually with a delta timer. So what we're going to do up here, where we initiate key, we're going to make a double and call it last time. And this will equal glfw get time. I think. Yeah, get time. And then in frames equals 0. Let's also make one called ticks equals 0. We don't need 2 semicolons though. In here we are going to do double current, that definitely said current time equals glfw get time. And just quickly, what I do want to do is check is get time in seconds or is it in milliseconds? Because if it's in seconds, it doesn't really help, if I'm being honest. Well, it can do, because we can see how long it took to execute. Oh, okay, so it's in seconds, but it does have milliseconds with it. That's always good. So, up here, not there, up here, we do want to make a double as well. And this is time per tick. This is going to equal 1.0 and then divide by whatever frame rate we want. So we're going to divide by a frame rate, tick rate, sorry, of 30. I think 30 is going to easily be enough here. And so what we then do is, rather than doing that, is if time difference is if time difference is greater than or equal to time per tick, then we are going to call our tick function. What we will do though is do timer plus plus, because this will be like an engine timer then, because this will all eventually go into the engine. And then down here just make a void called tick that takes an int of timer and send this timer. And what we'll do is that will go into a different thing. All of this, so all of the update stuff, will go into tick now instead. Oh, not good. Because none of this is stored globally. Of course. Let's pull that out of there and put it there. What else do you have to take? Key, level grid, level X, level Y. Int key is -1, that's fine, we can do that every time. And take snake out, put snake in there. Take level out, put level in there. Level X and level Y can also go in here. Level grid can go in here. Ooh, fuck, don't do that. There we go, level grid can go there. And sprite sheet as well can go in here. To be fair, all of that we've just done can actually go in our main.h file. Go us, we're actually making use of it. And let's, in here as well, do a double called time difference. So that's equal 0. Time difference plus equals current time minus last time. And then just at the end of the loop, before we update, we do last time equals current time. So all we do here is just work out what the time was, what the time currently is. We minus what the time was last time we finished the loop. So last time equals current time means we set the current time there. So that's what time when the loop finished. We then do set the current time. We then minus from the current time, we minus last time, so we get the difference in time. So we get how long it's been since the last tick. And if it's been longer than 1 second divided by 30, then we then tick. And we should also do ticks plus plus. And then what we should also do is just here make an int, call it current second, set it to equal 0. And then here we'll do if current second does not equal the integer version of current time, because current time has the decimal, so it's like 1 point something for the first second and stuff. So by making it an int time, it means we just ignore the decimal point and just take the second that we're on at the minute. If the current second doesn't equal that, so if the current second is actually less than that, sorry, then we are going to make current second equal current time. We are then going to see out, actually printf is probably better, isn't it? Printf Ticks. No, we'll do see out. We'll use see out. And see how ticks. Space TPS. Semicolon space. Frames. Space FPS. And then end the line. Like so. And then we'll also just pour this into this into a thing called render. Like so. And cut all of this out. Make a function called render, which should also be a void. That can go there. We need a view camera, which we will also define. Undo. We will also define that over in main.h, which is there. So all of that's being defined here now. That can all really be done. This can all mostly be done in the engines. The actual main file is going to look a lot smaller than this. When we run this now, we need to go into snake.cpp, sorry, and remove this bit. So the snake's going to move a lot quicker now, but hopefully should still only move at 30 ticks per second. No, because there's build errors. Of course there's build errors. Tick identifier not found. Tick. Oh, because we need prototypes. And in here. And render as well, by the way. Oh, shit. Void render. And in main.h. Void render, and now we should be able to run it because now they exist. We've told them it exists before we've actually done it. Let's move that. Okay, well that is interesting, isn't it? So it seems like more of a game of Space Invaders. Not Space Invaders, but it looks a bit Space Invadery. Ticks per second isn't working, clearly. I think I know why that is, because in this code here, we have to set that ticks equals frames equals 0. And also here we just have to put that frames plus. Level is clearly including the wrong file. Wrong sprite, and I'm not quite sure why that is. Yeah, I don't know why that had happened, why that suddenly changed. But we're getting a rate of about 59, so about 60 frames per second roughly. Oh, it kind of flopped a bit there. About 60 ticks per second we're getting though, and it looks a lot faster than that. Okay, let's just come out of that again. So we did set 30, didn't we? We did set 30. And frames should be going constantly. They shouldn't just be set in every 30 as well. Just in snake.cpp, if timer modulus 30 equals 0, then return. Does not equal, sorry. But what I do need to do is this bit of code, which is the bit that sets the key, actually needs to happen up here. So that it happens before we test, because then that way it will take the key inputs in and should still move relatively well. So the snake sort of jumps around. Hang on, it's just loading onto your screens. There we go, right, so it moves around and it takes key inputs no matter when you press them. So if I do that, it, oh my god, it goes really bonky. Okay, so I can sort of speed him up a little bit in a bit. Like I can set that to do it just 3 times a second rather than once a second, because once a second feels a bit slow and a bit jumpy. The problem it's having is snake drawing when it shouldn't, I think. If this is let's comment out the drawing of the head. And if I'm correct, the whole level should now not be heads. No, it is just black for some reason. So what we do need to do is in here, not there. For in I equals null, I is less than 400 I plus plus. That should actually be level X times level Y. And what we do is we do that level grid I equals -1. Level grid X dots right equals -1. Now we are drawing the head still, but there should not be heads all over the fucking level. No, there's not. And we are drawing the head. Wicked. The level's not drawn properly. Why is level not drawing properly, guys? Level's not drawing properly. For fuck knows what reason. If I'm being completely honest. Level X, level Y, what happens in level CPP, not H? Level X and level Y are stored. As you'd expect. Tile is stored. From what? Oh, fucking hell. So let's just... The whole level thing needs rewriting, because tile should literally just equal this. And then we don't need any of this. And then all we do is in this for loop, comment that out just in case I'm wrong here, we should just be able to do this tile dot set position is rotating this height, which is the tile X and tile Y. We need to get the tiles width. So int size equals this tile dot get size. So we're going to set the position I times size, j times size, and then this tile dot draw view camera. Test it now, and we should just now draw the tile. No, because it's still just doing it. Okay, what if I quickly try and change the tile so that, well, rather than just being black dots, we'll make it something interesting. And now run it. See if we get anything interesting now. No. Why not? It shouldn't be drawing just black, regardless, to be honest, because nowhere have I coded it to draw just black. So what have I changed? I've done this differently, haven't I? So let's comment all this out and just literally call tick timer render and then window.update. And now it should go back to how it was, because that's all we've added differently. Should not open the screen at all. Okay, everything's really slow, but the window does open. So why does removing all of that and just setting to tick timer render and window.update. Why does this now not load a window? Unless it does and it's just taking fucking forever to do it. My lord, it does, but... And this is what it looks like with no thing.